Hey, how's it going? Time to do more math. So today we're going to be talking about geometry and arcs and angles, specifically formed by secants or chords, tangents. Yeah, that's pretty much it. So there's going to be special relationships that emerge when these lines or segments intersect a circle. All right, let's get to it. First thing, so you have the notes. You can follow along. I would suggest printing them if you can, and then taking notes just like we would in class, or take notes in your notebook. Pause the video, whatever. Being at home, you're clearly going to have access to all the formulas on an assessment. So the main thing that I want you to take away from this, even if we were in school, I'd probably let you write down the relationships, because in real life, as long as you understand how to apply those relationships, you should be fine. I just want you to understand the relationships, and then look at those formulas when you're asked to do a quiz or a test. Frankly, the hardest part is going to probably be the algebra for some of the problems. So, and we can cover that. All right, here we go. So the first one in figure 1, the description is actually incorrect on these notes. It says when chords, secants, and tangents intersect in a circle, period, figure 1. I want you to take a look at that and see what's wrong with the original statement there. If you guessed that tangents are not featured in that diagram, you're correct. Those are only chords. And the reason they say secants is because these chords could hypothetically also extend beyond the shape and still have that same relationship. If you recall, a secant is a line that intersects a circle in two places, and the segment formed by those 2 points of intersection is a chord, right? All right. Next one, figure 2. So I see what they're saying here now. So now we can bring back tangents. So in figure 2, I thought they were going to restate that, honestly. So here we have, looks like a part of a secant. It's like a ray. So there's a ray, or it could be a chord. So this ray chord secant thing is intersecting a tangent line at the point of tangency. Okay. And then lastly, we have two secants. You'd call this a secant ray. Again, so you could have secant segments, you can have secant lines, just something that extends beyond the boundaries of the circle, intersects in two places. All right, so those are the three scenarios pretty much that we're going to focus on. First one. So we learned that if you have a central angle, right, the central angle is always the same measure as the arc, correct? Right. So here we have two secants or chords that are intersecting in a circle. Inside a circle is the key word there. Then the measure of the angle formed is equal to half the sum of the measures of the intercepted arcs. So intercepted arcs, again, if you have an inscribed angle, you learned what an intercepted arc is, right? It's the arc formed by the sides of the angle on the edge of the circle. So when you have a central angle that's like literally at the center, you don't have to do anything fancy. The central angle is equal to the arc. But if you look at this diagram here, we see that, let's take a look at, for example, angle 1. Angle 1 does not exist at the center of the circle. It's on the interior, but it's not at the center. So there's a new relationship that you need to focus on. So you would say, all right, well, what's the relationship here? It's related to these two arcs. So it's kind of like angle 1 and its kind of cousin, like intercepted, or maybe it's more of like a sister, vertical angle there, right? They're both the same measurement, so they both have their own respective arcs. Both those arcs are different measurements though, right? So the relationship is that angle 1 is the average half of the sum of those two arcs. So you'd write the measure of angle 1, in this case, again, they say half the sum of the measures of the intercepted arcs. That's the average of those intercepted arcs. So we're going to say the measure of angle 1 is equal to the measure of arc AD plus the measure of arc BC all over 2. You could write it as 1/2 times the quantity. I kind of like it like this better. And then the other one is, I will highlight it in blue. Let's use a blue marker here. So angle 2 here, that's going to equal, that's going to be associated with these two arcs. Those are the intercepted arcs. So why don't you pause the video and see if you can write down the formula for angle 2. Measure of angle 2 is the measure of arc AB plus the measure of arc DC all divided by 2. All right, so let's do an example. So here they want us to find the measure of angle AED. That's this angle right here. I'm going to call that angle X now. Makes it a little bit easier. And let's do it. So that means that angle X here equals 45 plus 109 all divided by 2. So let's bust out a calculator. This is a fine one. 45, 109, right? So I'm going to go 45 plus 109, and then just take that and divide it by 2, and we get 77. So X equals 77. Therefore, the measure of AED is equal to 77. All right. Now, of course, they're going to mix this up on us a little bit. They could always make this more challenging. There's going to be supplementary angles, like that sort of thing. So, yeah, let's move on to something that could be a little bit more challenging, like number 5 here. And so they want us to find CDE. That's a major arc, right? Looks pretty major. You could always use 3 letters to describe any arc. So just because there's 3 letters doesn't mean it's major, but it looks major. Major meaning it's greater than 180. But yeah, that looks like it's a major arc. All right, so we're going to call the thing we're trying to find, again, we're going to call it X, just because it makes life a little bit easier. So this highlighted blue arc is going to be X, and it's related to that interior angle formed by the 2 secant lines. It's 128, and then also that other arc. So you could say that 128 is equal to X plus 73 divided by 2. So that interior angle inside the circle is 128 degrees, and that's equal to the average of the 2 arcs. So we're finding one of the missing arcs. So the first thing we could do is multiply both sides by 2. That's why I like to write it this way, because it almost feels like a proportion. So 2 times 128, that's going to be 256, and that equals X plus 73 minus 73 minus 73. And yeah, I'm not going to mess around. 256, whoops, clear, 256 minus 73, that's 183. So X equals 183 degrees, and that means that arc CDE is equal to 183 degrees as well. Okay, so you see 2 examples there. They have you finding missing parts. So it's not always just going to be that central angle. Sometimes it's going to be one of the missing arcs. All right, so they're going to definitely mess with you. They very well could give you a situation like this where they ask you to find something like arc GC or something like that, and maybe they would have given you a little bit more information. They may have given you this arc, and then you would find X first, and then you would have to do like that whole 360 subtraction thing. So you have to just keep your eyes peeled. I could find an example for you right now, but I think we have too much to get through, and we're already at 10 minutes in this video. All right. Of course, in the homework, you can always ask me questions. Next one. So if the intersection is on the circle, that implies that one of the lines or segments are going to be a tangent, right? So there's going to be a point of tangency in this case. Or, I mean, of course, you already learned about inscribed angles. Those are on the circle too. So I have good news that the arc that's created by any angle, whether it's an inscribed angle or it's an angle that's formed on the circle between a tangent and a secant, it's always going to be straight up 1/2. There's no sums or anything like that. It's just straight up 1/2. So when you look here, I mean, they have the definition. It says, if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is equal to half the measure of its intercepted arc. So for example, arc AB, I'll highlight here in yellow, arc AB is going to be double angle 1. So you'd say angle 1 is equal to 1/2 of the measure of arc AB in this diagram. Again, they're just using those letters. Next, I will highlight the remaining portion of the circle, and that's going to be that blue arc. It's a major arc, right? And that's arc BCE. So can you guess what the measure of angle 2 will be relative to its blue intercepted arc there? It's not even a guess, right? You just know that the measure of angle 2 is equal to 1/2 the measure of arc BCA, or ACB. All right, so let's try these out. So here they want us to find, for number 7 here, they want us to find DEG, the big angle there, the big obtuse angle. So the associated arc with DEG is going to be, that's a lot of circle there. So you can see that that's simply going to be 1/2 of 308. So 308 divided by 2 is equal to, 300 is 150. So it's 154 degrees. I'm just going to double check. 308 divided by 2. Yeah. All right. So we can keep rolling here. They want us to know what arc XY is. So you have a couple things you could do here. I mean, arc XY is associated with the supplement of that 151 degree angle there. So I would probably suggest, I think it's a good idea to find the supplement, because what we're trying to find again is this arc right here. Oof, can I make that smaller? Yeah, I'm trying to find that yellow arc right there. So let's go ahead and find this angle. This angle right here is the supplement of 151, so normally it would be 30, it's 29 degrees. So this is a 29 degree angle, therefore its arc, how does it relate to that angle? So you'd say this arc is going to equal x, right? And we know the relationship between the angle and the arc. We're going to be able to say 29 is equal to 1/2 of whatever my arc is. It's x. I like to use x. You could literally write the measure of xy if you want, but multiply both sides by 2. So 2 times 29 is going to be the same thing as 40 plus 18, which is 58. 58 degrees. And then, of course, you want to go back and substitute 58 in over here so that we can acknowledge the fact that we answered the question. The measure of arc XY would have to be double its associated inscribed, or not inscribed angle, but angle formed on the edge of the circle. So you can see that they mix this one up a little bit. They are always trying to make sure that you're aware of all of the arcs summing to 360. You have supplementary angles there. I mean, anytime you have a linear pair, two angles that form a straight line, right? That's 180 degrees. They want you looking for stuff like that constantly. So those are big takeaways. So yeah, the complexity can always vary. But all right, lastly, So you have these exterior intersections. These are a little bit tricky, and you've noticed I've been highlighting the associated arcs more than ever. It's very, very, very important that you highlight the arcs that are at play here. If you don't, you will really struggle. So, all right. So let's get started. So again, this is your angle and arc relationships. So if you have two secant lines, right, that like emanate, that come from like a single point, and they're going towards a circle like you see here, okay? The relationship between that angle that's formed between those secant lines, since it's on the exterior here, it's going to be related to the intercepted arcs again. There's two intercepted arcs. Can you guess what the intercepted arcs are in this diagram? So, or could you, I wish you could tell me right now, but if you guessed BD and CE, you'd be correct. I want you to think that you're like looking through a telescope or something like that. Like it's a little peephole at angle A, and like what portion of the circle, what portion of the circle do you see when you're looking through A? You'd only see that yellow arc and that blue arc, right? So the relationship that exists here is that the angle is going to equal half of their difference. So the good news here again is it's always half, right? So when the angle's on the inside is half of the sum, when the angle is on the actual circle, it's just straight half. And when the angle is on the outside, it's going to be half of the difference, okay? So you would say the measure of angle of arc CE minus the measure of arc BD all divided by 2. Notice how I started with the big arc minus small arc. The one that's further away is always going to be bigger because it's like projecting. Like the further your projector is from a wall, it gets bigger. It's like when we did dilations, right? So yeah, it would only make sense that you go big arc minus small arc. What would happen if you did the small arc minus the big arc? You're correct. You'd get a negative answer. You don't want negative angles, right? We want positive angles. So it's big arc minus small arc. All right, so that's when you have two secant lines. Now, if you have a secant and a tangent, that's another type of combination here. Here's the point of tangency. And then, so we have another relationship. I would suggest that you pause the video and see if you can figure this one out. Just maybe take a wild guess. It doesn't have to be wild either. It could be a very not wild. If you guess that that's one of your intercepted arcs, you are correct. And this is the other intercepted arc. Same idea. If you're looking through angle A here, what portion of the circle can you see? And you can see arc BC and you can see arc BD. That almost feels, that could almost be a semicircle. It doesn't matter. The whole concept is that it's half of the difference. So why don't you write that down? The measure, they didn't give me a lot of space there. Oh, I see. They want us to write down the line underneath. All right. So the measure of angle A equals, here, let's write it this way just for fun. 1/2, and then say the measure of arc BD minus the measure of arc BC. There you have it. One more combination. Two tangents, right? So this one seems, I think the hardest one is probably the middle one there. There's only two intercepted arcs here. Okay, and they can get really playful with this because there's only two portions of the circle now. There's only two arcs at play. They can just give you limited information. You have to be creative. So hopefully there's an example of that. All right, so the angle is going to be equal to, again, let's highlight those arcs. Here's one intercepted arc. It's also nice to put those points of tangency in. They're implied. You should probably just plot them there. All right, and we have this blue arc that goes around the circle as well. Half of the difference, same idea. So we have 1/2 times the quantity, the measure of arc, BDC, right? That's clearly major. BDC minus the measure of arc, BC. So those are the three relationships. So it's hopefully you'll have these notes when I eventually give you a quiz on this. And yeah, feel free to just use them. I'll be really happy if you just know how you get the you get the relationships that exist, and you're able to solve the problems. So let's do a couple of these, and then we'll call it a lesson. We're at 20 minutes. Amazing. All right. So angle KLM, that's right here. They want us to find that. So I'm going to call that X for simplicity purposes. So here we're directly finding the angle. Let's highlight those intercepted arcs. Here. They have them labeled. That's wonderful. So X equals 1/2 of the difference of those arcs, 140 minus 66. So 140 minus 66 is 74. So it's and then divide that by 2. All right, so that's 37. So X equals 37. That means the measure of KLM is equal to 37 degrees. All right. So now 12 is a good question. I like that. So why don't we try that one? They want us to find the measure of angle BCD here, BCD. But in this case, we have 2 secant lines again. I'm gonna put a little X there because that's what they're having us find. And but the arcs that we need are these 2 arcs. Notice there's not a measurement, and let me get rid of X here because it's confusing this. I'm gonna make sure that X just points to X degrees, points to angle C there. And you could actually call this angle C. There's no other, I don't know why they're using 3 letters. There's no other one there. So they didn't give us that little blue arc, and we need it because right now I have X equals 67 minus little blue arc all divided by 2, right? But is there a way to find that blue arc? So why don't you pause the video and see if you can find it out, figure it out. All right, so welcome back. If you said, hey, you know what? This guy right here is a diameter, and a diameter cuts a circle into 2 equal parts, aka semicircle, aka 180 degrees, right? Then you could say, well, if we have 67 degrees of arc here, and then another 94 here, how much is remaining there, right? So all 3 of those arcs should add to 180, right? So we're just gonna say, a little side mission for us is we need to find the measure of arc, the measure of arc BD, right, plus 94 plus 67 equals 180. So we could just do 180 minus whatever the sum of 94 plus 67 is. Minus 94 minus 67, right? Let's just isolate. So 180 minus 94 minus 67. 180 minus 94 minus 67 equals 19. Right? 94, 67, 94. So that's going to be 19, right? 19. All right, so cool. Now we can come in here, and in green, I'm just going to label that 19. Ooh, that's just hard to read. All right, 19 degrees. And now we can plug that in. So 67 minus 19 divided by 2, that's how we're going to find that. So 67 minus 19 gives us 48. And let's take that answer and divide it by 2. We get 24. So X equals 24. And we can write the answer here because X represents this angle, 24 degrees. Lovely. All right, let's keep going. More examples. So they have lots of secant examples here. That's nice. Here they have us finding an arc. I guess we could do that one. That's pretty good. They're doing the same thing with 13, but we're going to skip 13 because that's unlucky. Okay. If you don't mind, I'm going to just have myself a sip of coffee. Just like old times. All right. So yeah, why don't you try this one and meet back with me in a sec. 35 is our angle, and that's going to equal to half of the difference of X minus 46. Oh, I did a bad thing. I did not highlight the arcs. I told you to do that. I see them there. And they ask us distinctly for QU. So cool. All right, so I'm going to double both sides to just take care of that 1/2. You could distribute it if you want. I think it's easier to just double both sides, times 2, times 2. So rather than distributing the 2, I'm just going to combine 1/2 and 2. That becomes 1. 2 times 35, we all know is 900. Just kidding, that's 70. 70 is equal to x minus 46. Add 46 to both sides. X is equal to 116. 70 plus 46. Yeah, I should know this. Whoops. 46. Yeah, that's 116. Okay. So if x is equal to 116, so is q. 116 degrees. Okay. So again, they don't always ask you for the angle. Sometimes they're asking you for the arc. Over here, they want to know angle KLM. This time they are asking us for the angle, so we're going to call that x. The two arcs that are at play, this arc and this arc, maybe again, it wouldn't hurt you to put that point of tangency in that really divides the arcs there. So there's two intercepted arcs. KLM is going to be equal to half of their difference. So it's going to be x equals 1/2 of 135 minus 33. So we're going to have 135 minus 33, and then take that answer and divide it by 2. Whoops. Let's let's try that again. That's supposed to be divided by 2, and it's 51, which we could have done in our heads. X is equal to 51, therefore KLM is also equal to 51. So I'm sure you guys are having a good time with this. I know it's getting late. We have it's almost half an hour, but why don't we try another one? Just because I think the more the merrier. Obviously, you could skip these. All right, perfect. Look at 16. 16 looks kind of tricky here. And the reason 16 is tricky is because in order to find the measure of angle ABC, again, we're finding angles here, no doubt, but this one's a tricky angle question. So you could either be finding arcs or angles. In this case, we're going to actually have to find a missing arc first, because in order to find angle B, or ABC there, right? So let's label that X, because that's the star of the show, right? We really need to know what X is. We know that X is related to that light blue arc and that yellow arc, and X should be half of their difference. So how do you find that light blue arc, basically? If you guess that you have to, you know that all three of the arcs, the not colored arc and then the light blue and the yellow, should add to 360, you would be correct. So we can write down that relationship. We can say, I'm going to call this Y temporarily. I'm going to say 62 plus 88 plus Y equals 360. So that means if we just subtract minus 88 minus 62 from both sides, we should be able to get that missing arc. So 360 minus 88 minus 62. 360 minus 88 minus 62 equals 210. 88, 62, 88, 62, 210. So that means that this arc right here is 210 degrees. Now we are able to go ahead and solve this. So that equals X equals 1/2 of 210 minus 62, and X equals 210 minus 62, answer divided by 2, 74. All right. So there you have it. So yeah, that would have been 74 degrees over here as well. The only one that we haven't done yet is this. There has to be one. Haha, here we go. Perfect. We'll end with this. We have 5 seconds before 30 minutes, but all right. So we need to find the measure of angle Q there. and that's on the outside. They only give us one arc. And the arc that they're talking about here, I know for a fact that they meant to. There's really no nice way to do this with a circle arc, but normally with angles or with segments, you assume that the measurement that's written there is just between the 2 points that are nearest. This 313 degree arc is clearly not arc SR, right? They are 100% implying that this big yellow arc that I'm highlighting right now is 313 degrees between these 2 points of tangency. We have 2 tangent lines. We need to know what angle Q is. So angle Q, I'm going to call X. Now we need to know this other arc that I will highlight blue. So what is the other arc going to be in order for me to be able to find X? Because right now I know that X is equal to half of the difference of that big yellow arc minus the blue arc. So if you guessed that it completes 360, the rest of the circle, you're correct. 360 minus 313. 360 minus 313 is equal to 47 degrees. So that's 47 degrees of arc right there. Now we have enough information to solve this. So we know that X equals 313 minus 47 all divided by 2. I'm just writing it the other way to mix it up for you. 313 minus 47. Take that answer and you divide it by 2. So answer divided by 2 is 133 degrees. So this is X equals 133 degrees. Awesome. All right. So hopefully that was helpful. Good luck with the assignment. And of course, let me know if you have any questions on anything. See ya.